Today we have this 1 terabyte Seagate Rosewood drive that I've spoken to you guys about it before. I actually made a couple of videos about it. This is one of the most common drives that we get in here, right? So this is the bread and butter of data recovery. I'm gonna put it here. So I have a couple of drives here. I wanna show you guys some difference between the three here. Well, one of them being the patient, the other two are donors. So generally speaking, when you replace heads on a Seagate hard drive, you need to match the preamp. The preamp is inside or on the head stack assembly. It's a little chip here that I'm gonna show you. So this is for a 3.5 inch. Obviously this is not gonna fit in here, but this is for a 3.5 inch drive, and that's basically the preamp there. So that preamp is part of the head stack assembly. It comes in, with the head stack assembly, you cannot replace it, and that's basically it. So you need to match the preamp before, or find out what the preamp is of the donor to make sure it matches with the patient. So a lot of the time in these cases, you don't really have a way to find out what the original preamp of the patient is. So you're gonna have to do some guesswork. So in this case, we use the date code. If you look here, the date of manufacturing is 02 October 2016. If you look at this date of manufacturing number here, this gives you a little bit more information as to where this drive came from, what type of preamp it should have. It's not a guarantee, but we're making an educated guess here, or you can call it a good guess, so to speak, as to what the preamp could be in that we're dealing with here. So these two drives are two separate drives, actually. There you go. They're very close to one another, but they have different preamps. So the preamps are up here. I marked them. This one is 8202. This one's C202. Generally speaking, you cannot mix and match. For some models, you can get away with it, but we're not going to go over that in this video. This video is just strictly focusing on what preamp to use in a certain situation like this one. So I have not opened up the patient drive yet. So this is the patient. I have not opened it up yet, but from the description, from what I've seen, they said it clicks. So the first thing to do, actually, before confirming that it clicks, is to open it up and make sure that the head stack is parked. There's no interference with its movement or anything like that. You don't want to power this on after the customer tells you that it clicks, only to have it cause more damage. So the general rule of thumb is when you have a drive that comes in clicking, you do not power it on to confirm that it's clicking. You open it up first to make sure that the head stack assembly is free to move. And yeah, that's basically it. So back to these two. These two drives here, they're the same, slightly bit different. The date code on this one on the left here is from 2018, while this one is from 2016. Now, there's another rule for these Rosewood drives that whoever's in data recovery follows, and it's that this is the most common preamp. So the 8202 is the most common preamp. The C202 are not the most common. They're actually pretty hard to find, at least from the data sheet that I've gathered over the past, and based on the data that I'm using. So we're gonna go ahead and assume, right, take an educated guess that this patient uses the preamp of C202 based on the date code, that we have here. So basically, I will use this donor to replace the head stack assembly in this patient, and hope that it works. Again, in older Seagate models, actually most families, but this family, the Rosewood, you can find out what the preamp is. So you can get more info from the ROM about what preamp it uses. But on the Rosewood drives, there is currently no way to find out what the preamp is, at least according to what I've read and seen and stuff like that online. So I'm sure there's someone that has a way to do it. It's just it's not mainstream yet, and it's very secretive, I guess. All right, on to opening this drive up. So what I do in this case is I start with the bottom right corner, holding the drive this way. It's just a preference. It's not anything that is you know, mandatory or anything like that, really preference. The goal is, at the end of the day, is to preserve the label here, because this drive is sealed only with this label. So you'll see once I remove it, once I take this label off, you'll see that there's nothing really holding or containing the air besides this label. So yeah, let's just get right to it. So I start from this corner, I dig in here like so. You just want to dig in just enough, you lift it, then I start peeling it slowly. Make sure you take your time to peel this off slowly if you are doing this. You don't want to rush it and stretch the label, because then you can't put it back on properly, and that's part of what we see here all the time, is that this label is improperly removed, and sometimes they're even missing completely, so you can only imagine how difficult it is to guess what, you know, compatible donors you can use in this case. So you just slowly remove it. It's a little bit sticky and tricky to remove, but if you just take your time, go slowly at it, it'll you know, come off. Once I get to this side, I'll actually start on this side, removing this here. There you go. So you have two of these, and then remove this side. Yeah, it's funny focusing so much on this label or putting a lot of emphasis on it. It's because this is really the only thing that's holding this drive together, really. I mean, aside from the screws that are on the covering. But yeah, so you see exposed, there's nothing allowing or keeping the air in there besides this. So you want to make sure that this is intact when you are removing it. So just slowly go around. All right. All right. So yeah, there's that. Came off just like so. I'm gonna put it somewhere here. All right, so I've marked everything here. You don't want to mix this with the donor or anything like that. So yeah, it's very important that you have everything marked. Normally I do use the stand for the head swap, but in this case, I mean, I've really gotten used to working without it. It's a bit easier to move the drive, put it away, you know, if you need to do anything like that. So let's get the donor here. So let's see. Yep, that's it. All right, we're gonna put the patient aside. We're gonna do the same thing to the donor here. So what I personally think is that this may not work. The reason I'm saying this is because, yes, these two have close date codes, but the C2 preamp is really, in my, again, you know, according to the data that I've gathered, it's rare. So for me, what I normally do is I go by my, you know, statistics. I go what I have and what I've gathered over the time. So I use the 8202. But just for this video's sake, I'm going to go ahead and try to use a donor that's close in terms of the data manufacturing to the patient, and let's see if it actually works.
Is the date code a guarantee of what
It's not a guarantee, no, that's the thing, yeah. So it's actually it's just a guess again. So we're making an educated guess as to what it could be on the inside.
What happens if the wrong preamp goes in the drive?
Nothing major, it just won't work. You'll hear some clicking and that's about it. So with this one, I can be a little bit rough. It is the patient. I don't need to worry, the donor, sorry. I don't really need to worry about it too much. All right, that's that. Make sure we focus there. All right. So just gonna remove the cover. This is the new bench, by the way. So I don't have a mat here yet. I have one that's on the way. The one I actually had is a bit too small, and I don't want to bother using it. So obviously, when I work on these, there is a mat underneath the drives to make sure that there's no, ESD or anything like that. Let's go ahead and get this over. So before I do anything, let me just quickly mark this to make sure that there's no... So we're going to mark this as D here, and then D here. I'm going to write a little P here, and a little P here, just so that there's no mix-up. For you guys, it's probably going to look the same. I mean, I know which one is which, but... All right, so let's get this off. So I always start with getting the headstock assembly off the donor first. The reason is you want to sort of get in the rhythm and pretty much make sure everything is working in your brain and hands wise and stuff like that. So just to get in the rhythm, so to speak, you want to first extract the donor. You don't want to go in straight to the patient, especially if this is the first, let's say, recovery of the day or anything like that. It's just a habit of mine that I do. It's not something that's mandatory. Again, it's just a preference in what, generally speaking, should be done. Because if you mess up the donor, no problem. You can always get another one. Take it from there. So on this one, you have to put the screw back on. The headstock assembly actually does not move well when the screw is not placed in. So I'll show you guys. So this is with this screw, and without the screw, it would sort of get stuck in between there. So yeah, let's get right into putting the combs in there. So this is a single platter, 2-head drive. We want to make sure, obviously, that the patient is the same. Generally speaking, it's better to see if you can get a match in terms of the number of heads with the platters. But if the patient has an extra head or an extra platter or anything like that, you need to match it obviously with the donor that you're using. So this one is just a single platter and just 2 heads. So let's make sure that that's the case for the patient as well. Again, this is the first time I'm opening the patient, so the customer said that it was clicking. I hope when I remove this top cover, we're not going to have any sort of damage to the platters, because I've seen that one too many times. All right, sweet. So this one looks relatively clean. Let me just get a video there. There you go. So it looks relatively clean. Nothing out of the ordinary. What I do is I use a green light just to make sure that there are no physical issues with the platters themselves, scratches or anything like that. This one looks pretty good for the most part. No fingerprints or anything like that. The platters actually look relatively clean. So
How many drives do you get with scratches and marks on the platters now?
on this model, it's a lot. It's pretty bad actually. We've made a video together actually on how it looks. So, but like just yesterday I had one that came in with a What looks better actually, with light or without?
It doesn't matter. The camera auto adjusts.
It's just
It'll be less light.
yeah. I can't tell. Maybe we should get a screen later on because I can't tell how this looks at all.
Having a screen that's inside the bench.
Inside, maybe on the corner or something. Yeah. So this is the patient. This patient does have a single platter with 2 heads. Some of these 1 terabytes do come with 3 heads, 4 platters. So you know, it's another thing that you'd have to just pay attention to. Let me just close the patient, put it aside, and let's work with the donor here. So first, we're going to take off the connector for the preamp. So this is a T5. Let me actually get you in focus there. There you go. So you want to remove this connector. Just carefully go underneath. There you go. More zoom. Good. All right, now we take the head comb. So this is a, where is this thing? So this is what the head comb looks like. It's a bit, let me zoom in actually on it and get this out of the way. So this head comb is not like your average or the one that's that you usually see here. So you see it has a gap in between, and the reason is there's very little room to work with here on this drive. So you don't have a lot of room between this ledge here and the the parking ramp itself. So what you'd have to do is you'd have to insert the comb inside. It actually goes over the platters, so it separates the heads and then it goes over the platters. So the heads go over the platters, the parking ramp comes off, and then you can you can take out the head stack assembly and then work with it. So just a little bit of a description before I do it. Some of you were asking to just describe it before I do it, and that's basically the process. So you insert this head comb here, and the heads go over the platters and they're separated. Obviously you don't want to touch the platters, and then you extract the head stack assembly that way. So let's just get right to it. So what I do in this case is leave everything there, take this here, there you go. All right, so it's in there now nicely. Let me just lower the chair a little bit. There is a pin that you have to put in here. It's just with this head comb that I'm using, it's a little bit tricky to get the pin to fit and stay in there. So it's not the end of the world if you can't get the pin in there. It's not a problem. But the idea is you don't want this to come out once the head stack is taken out. So if this leaves its position and the heads or the sliders touch one another, basically you'll need a new donor, and that's what you're trying to avoid here. So let's go on to the next step. So the next step is to take the heads and slide them over the platters like so. So what we're going to do is we're going to take the head stack assembly, move it over the platters to make room so that we can take it back out. It's going to look like this. So you drag it slowly over. First, you want to make sure that nothing is interfering with this movement, because if you feel any resistance in terms of when you're sliding the head stack over the platters, you immediately stop. You don't want to continue. So just briefly, slowly go over the platters. Make sure that you have some movement there, and you do. So we're good to go. So we just place that there. You use a pentalobe 4 to get the screw out. So take the preamp out. Now you have the headstock assembly that's free, and it's no longer on the preamp. I'm sorry, on the parking ramp. If I said preamp, sorry for that. Yeah. So let's move the actuator magnet. Where's my 2.5? There you go. All right. Removing this magnet it's a little bit tricky. What I like to do is I like to go from this angle here. Maybe zoom out a little bit. I like to go from this angle here, lift it out, and then pull it up. So it'll look something like this. So dig in just a little bit. So this one's a little bit tricky. There you go. So that's basically it. You don't want to use, forceps or anything like pliers or anything like that to get underneath this side, because you can nick the coils here for the headstock assembly. So there are these. Let me see if I can get a good zoom on that. So these windings here are very sensitive. They're even if I were to actually touch it with the tweezers right now, it'll sever one of the copper connections, and basically that wire is done for. You can't. There's nothing you can do to fix it, or you can't solder it back or anything like that. So make sure you're very careful when you're removing this magnet, which is actually relatively easy to remove. So it's not too bad. Let's remove the headstock assembly now. Whoa. Getting this thing off is a little bit tricky. You can't just pull. You can't just insert tweezers and pull it out. It's not secured by a screw on the bottom. So basically it's just sitting there, and the only thing that's holding it in place is the screw that was on top that I just removed. So to remove it, you put the tweezers to clamp on the side of this thing. So there's a hole here, and then there's a side on the headstock assembly itself that you grab. So basically this, and then I lift with this opener here that I have, and then there you go. It just comes off just like that. So all right, so we've extracted the donor headstock assembly, and let's do the same for the patient. This one I'm not going to get into too much detail. Obviously, it's already been done, so you guys get the idea here. Let's put the screw back on, as always. One thing that I do here, some of you may have noticed, maybe not, is when I'm using the screwdriver, especially here or anywhere, I have a support. I use the support finger just in case something happens and my finger slips, or anything like that, you don't want to obviously scratch the platters or cause any damage. So when I do go in to remove something, I always, let's say I want to get this thing off, I always use the support finger to make sure that my hand does not, go anywhere like that. So let me just zoom out a little bit more. There you go. All right. Let's go ahead and remove this connector. Okay. These Seagates do still use the rubber gaskets here, so you want to make sure that you don't have anything, here, and none of the rubber gaskets must come off with the connector itself. So, all right, let's bring the head comb. There you go. Getting it to fall in is a little bit tricky, but honestly, this is the best head comb that I've used for this drive, so I have to make do with it. And luckily, no issues with it or anything like that. It gets the job done. Again, the pin is missing here, but it's not a big deal. There's enough pressure when the head stack assembly is released for for the heads or the sliders to sit on there nicely and not slide out or anything like that. All right, so let's go ahead and again, what you want to do is you want to make sure that you're free to move the head stack assembly over the platters without any resistance or anything like that. So gently just test it first, obviously. Make sure you can slide over the platters there. Okay, and this one looks like it does. So we're gonna go ahead and slide it over there, just slowly. All right. Take this off. All right, now we've freed the head stack assembly. Let's remove the magnet. Again, sometimes removing the magnet is tricky, so just be patient and try not to cause any damage. On this one, you can start from here too, but in this direction you're too close to the platter, so you don't want that. It's not something that's that's safe to do. So I always go on the opposite side and remove it. So they sell these magnet removers. They look like, I don't have anything here to show you, but they're basically just another magnet that sticks to this and you just pull it off. I've honestly found that to be a little too risky to use, so I just use let me get this out of the way. I use some just pliers and yeah, this opener here that I have. So yeah, on to removing it. So make sure you're not touching the platters or anything like that. And let's get to it. Okay, so this thing slid out a little bit. Hold on. All right, cool. All right, so we're gonna remove the magnet. Go into here, like so, lift it up. All right, cool. So that's out. There you go. All right. So we're gonna mark this as the patient head stack assembly. Gonna write a little P on it. All right, now we're ready to insert the donor head stack in there. So make sure it's good. There you go. All right, cool. So that's in there. First thing you want to do again is to put the screw back on. Okay, it's in there nicely. And then put the actuated magnet back on. So in this case, actually, I put this thing back in place so that we don't have any issues with it. Make sure this goes over here smoothly. Yeah, it does. Okay. Let me just get this off. Okay, cool. What? Move the drive up? Yeah. Okay, cool. All right, so what I do actually is I'm going to leave this out for now because it's before you're putting the actuating magnet on. It interferes with. Let me get you guys a closer look. So what I do is I leave this thing off. I don't connect it in the PCB just yet, so I can put the magnet back on. And then doing that, I just hold the drive this way. I hold the head stack assembly, make sure it doesn't move onto the platters this way, and yeah, just make sure that it doesn't slide back onto the platter. So I put the corner, I hold it this way, I put this corner in like so, the other corner should fall in place just like that. Make sure it's nice and snug in there, no movement, and yeah, you're ready to close everything up. So let's grab this thing. All right, so we slowly slide the. Make sure that you can move it. Okay, so you can't move it. So something is stuck here because this head stack assembly is not free to move. And I think I see what it is. This thing needs to be pushed a little bit to the side here. think the stopper is actually keeping it from closing up. So let's just double check that. Let's see, can it move now? Nope, doesn't move. All right, so let's see what's going on. Okay, so now it's free to move, but for some reason when I'm putting the stopper, it's not free to move. So something with the stopper for sure. Let's inspect it, make sure that everything moves. So the stopper is actually here. Let me get this out of the way. The stopper is this thing here. So sometimes this doesn't sit right on the corner of the headstack assembly, and then the headstack assembly cannot move. So you want to make sure that this thing is properly placed. So let's try that again. Okay, so I'm going to take this. Okay. All right, there you go. So it can move now, and it's free to move. There you go. That's why it's very important to just take things slowly. Don't rush it. I mean, when I'm doing this video, I'm taking things extra slowly, actually, and I can't work at that pace. But it's not a major issue or anything like that. Just have to take it slow, extra slow, so that I don't cause any damage. So we're gonna slowly slide the headstack assembly over the platters again. Test the beginning, make sure that it can go on there. This one can go, so we just go ahead and insert, push it in like so. Take the screw for it. All right, and then just finish that up. So notice the movement that I'm making. It's very slow, and you don't want to, again, damage the platters or scratch them or anything like that. So take your time, and if you are actually even doing this on your own, make sure that nothing is in the way or anything like that. All right, so when I remove the head comb, I simply push this a little bit forward and then slide it out gently. So just like that, comes off as so. Put the headstack assembly connector back in there. Make sure the heads are free to move. All right, they are. Let's remove the screw for the headstack. Check everything, make sure everything looks good. Make sure everything is flush before we close it up. What I like to do is a quick inspection with the green light. Make sure there's no debris or anything like that. And as you can see, this looks really clean. There's nothing, no issues or anything like that. Yeah, this is pretty easy to see, actually, the scratches and whatnot with this light that are on the bench. And that's what this light is for, really. Helps in terms of viewing imperfections and stuff like that on the surface of the platter, any fingerprints, marks, etc. All right, let me just put some air here. Just a little bit, not too much. I saw a speck of dust on the corner here, so I only put air in that direction. And take the cover, clean that off as well. And one more screw we need to put back, actually, before I close this up. It's this guy here. So, all right, so that's in there. And then this one we can put it after we put the cover on. It's not a big deal. All right, so just close this. The screws are different here, so you want to make sure that you're putting each screw in its respective place. Like the one that holds the head stack assembly in it's a Penlobe 4. The others are T5s. A lot of you ask, well, what screwdriver do you use? So T5 and Penelope 4 for the most part. Actually, I think, yeah, and on the back Phillips, of course. So yeah, you need 3 screwdrivers if you're doing any work on this drive. One thing you generally don't want to do, and it's something that's good to practice, is place your hands over the platters when you're working. Now, I did this in this video when I was removing the actuator magnet, because it was a bit difficult to actually remove it for some reason. Just one of these cases. I guess making a video and explaining it has something to do with it. But you ideally want to avoid putting anything or hovering anything, whether it's your hands, screwdriver, or tweezers or anything like that over the platters, because you don't really know what's going to happen in terms of you slipping or something like that. It's not needed. But if you've done enough of these, which I have, it's okay. It's not a big deal. You also have gloves on, so it's it's one of those things where it's just preparation, I guess. And let me just close this. So I align it with the breathing hole here, like always, like so. Make sure that it's good. So that side is good, and then you just run across this way. All right, this is all put back together now. We're ready to hook it up to PC3000, see what shows up. One thing before I actually go and hook this up to PC3000, I want to inspect the patient headstack assembly on the microscope, just to double check that there is no platter damage, no debris, no contamination or anything like that on the sliders. So let me just go ahead and quickly connect it to that. Generally speaking, you want to make sure that there's no debris on the heads or anything like that before powering the patient drive back on. So this is the patient head stack. This is the heads that have failed, and we're inspecting them to make sure that there's no debris or anything like that on them, and there's no damage of any sort. So this one looks good for the most part. Make sure a little bit, zoom in more there. Yeah, so for the most part, I don't see any shavings or anything like that. Going here, everything looks clean. No, marks or, scuffs or anything that would indicate that you have platter damage. So, yeah, you want to check the edges. Sometimes the edges give it away. Let me get the focus in on this. It's really hard to focus in because I don't want to put these down, but my hands is moving. There you go. So, awesome. So, yeah, for the most part, looks good. Don't see any issues with it here. I'm gonna get better. Try to get a better zoom and focus on this thing here. So, that's pretty focused. So, normally you'd have some debris or damage around these sliders, which are So these are the sliders here. So let me just get you a close up. So this here is the slider. This is where the read write heads are. So read write heads there. You have sometimes when the platters are damaged or these, these two sliders crash into the platter or anything like that, you get debris around all around here, here. You would see it immediately. So this one, for the most part, looks good. Doesn't look like it's bent or anything like that. See there. They look pristine. Bottom looks clean as well. So, and I just make sure the bottom one as well. There you go. All right, yeah. So for the most part, they look good. Yeah. So data recovery really is a process. It's not anything that you just rush to doing and hope to get good results there. So. All right, so this is the patient. All right, so it's all closed up. We're going to go ahead and plug it in PC3000 here. We're going to connect the terminal port. Connect it to SATA 1. And let's see what happens. We will go to power monitor here. This version of PC3000 actually allows me to see what the drive is drawing in terms of power, which is good because a lot of the time you can tell what the head stack is doing or trying to do without having to put your ear to it. So let's go ahead and power that up. And I'm going to put my ear to it anyway to make sure I don't hear any clicks. Okay, so no clicks, but the head stack is definitely doing something. So it's seeking. So this is most likely just background processes that this drive is doing. So we want to go ahead and disable that, make sure that nothing is interfering with our ability to read the user area. So let's go ahead and launch utility. Sweet. So we get ID. We want to make sure that this is actually the correct ID and serial number first. This hasn't been anywhere else, so it should be, which is good. We're going to go ahead and select utility start. This is okay. We're going to leave that. Let's see if we have terminal access. We do. Diagnostic port locked. Okay, so we're going to quickly apply a patch here. Let's do read ROM. Okay. Let's read it via ATA. I don't think it's no. Let's do boot code. 6. Okay. So what it's basically doing now is it's reading the ROM before we patch it. That's all there is to it. So this software is basically doing all the work. It's a button that I press, and yeah, it does all the good stuff. All right, so let's wait for it to finish up here. All right, so result, okay, as you can see there, so we're good. Let's power it off, power it back on. See what terminal has to say. Wait for the drive to get ready. All right, sweet, got ready. Now we can go ahead and patch it. So we're going to quickly patch it. There you go. And let's do that. So these errors here tell you that this drive is having a lot of relocation processes in the background. That's what we're after, and that's what we're trying to disable. So these spikes here that you see are basically what's happening in this text here. So this is not just gibberish. This is actually very useful information for the data recovery technician that's working on this case and trying to get the data, because it tells them a lot of stuff. It tells them that, hey, this drive is actually relocating sectors or moving them back and forth, and you want to make sure that you stop that. So yeah, that's what it's doing. So let's wait for this thing to finish. Okay, so we're going to send it the handshake. Okay, so some background processes again. All right, and we're going to go here and just reload the firmware. Try to get this to show up. Okay, so it's not. Let's, let's do this. Power it off. Power it down again. Let's give it on lock. Okay, cool. So let's auto detect. Restart utility. Okay, so the drive is not playing nice, but that's expected because it's, surprise, surprise, a Seagate. So let's see what we can do here. So let's see. Do we have terminal? Okay, we do. We had at some point. No, we don't. All right. So basically, we have to wait for this to finish. Then I can have access to terminal. There you go. All right. So now we have access to terminal. Let's see if I can read file 93 actually. Okay, so I can. And let's check a couple of things here. Let's check. Come on. Okay, stopped responding to. There you go. Getting this drive to work with the terminal is tricky sometimes. So, like in this case, it's being a little bit annoying. You know, it's giving me access sometimes, sometimes not. So, you want to make use of the time that you have with this. So, quickly check some entries here. Make sure that there's nothing going on. And I can't actually check any defect lists with this thing. Interesting. Let's see. Okay, let's wait for the background processes to finish. All right, so we have terminal now. Let's try to edit a file here and see if we can actually read it. So 03 93. We're gonna leave that up. So the relocation processes in the background, the activities that the drive does just is located in this list. And this is what you want to disable and make sure that you don't have any of them enabled, because it will prevent you from getting access to the user area. Basically, that's what we're after here. So we're going to hit disable prefetch and that, hit OK. Actually, before doing this, we want to make sure that the heads can write. So let me actually, no, stay on this one. Where is... First, let's save it. 93. Yes. All right, so we want to save this to there. So we're going to call it 93. All right, looks good. All right, cool. And now let's try to edit some things within, see if this will actually let us do that. No, we're gonna do disable, disable. We're gonna go ahead and write it to the drive. Oh, first we have to make sure it's actually indirect. So make sure we're writing it indirect. This is okay, okay. And then we're gonna try to write it this way. Okay, so let me run a couple of things on here to make sure. So again, it's giving us the background processes. I could not edit the system file 93. We don't, I mean, I'm getting ID here and getting the full, info about the drive, but I have not tried to access the data by, sector edit. So check sector 0 and the last sector, etc. Let's wait for this thing to finish, and then, but I could not load the utility when I restart to this utility. So normally when you patch a ROM or anything like that, you want to restart the utility that you're working with, or when you try to edit any system files or anything like that, you want to try to restart that utility. But I could not get it to ID or load any of the service area, really. So for me to have sector access now is highly unlikely, but I'll try once this is done. As you can see here, all of this indicates that the drive or the head stack assembly is actually working to relocate bad sectors, stuff like that. All background processes that we want to disable, and that's what I'm after right now. All right, so we're gonna let this just finish up until we have. Okay, there we go. All right, let's run some commands here. Okay. Let's refresh the ID. Try to refresh. Okay. Hopefully, yes, no, maybe. No. Okay. Let's power it down. All right. I think this is safe enough now for us to have sector access. Let's see. No. Okay, so definitely something else going on. So let's try to power it down, power it on again. Let me just get rid of this. Let's see. Let's restart utility. Utility, this one, auto detect. Yeah, so the drive is constantly getting stuck at this utility initialization screen. It could mean that the heads are incompatible. So that's possible. Let's just do a couple more things to confirm that. Let's wait for this. Okay, so there's no. Let's see here. Okay. Make sure there's no clicking or anything like that. And there isn't. That's the thing. So this is a good example, actually, of what could happen when you put incompatible heads. They don't have the ability to write or read in this case. And that's where we're currently at right now. So let's try one more time to see if we can do anything with this system file. So 03 93. As you can see, the stuff that I unchecked are probably checked back. Yeah, so everything is already checked back because I cannot write with this head stack that's in there currently. So this donor was not ultimately compatible. Let's try one more time. Doesn't really. Let me check one thing here actually. Okay, so let's go here, indirect, and let's try to write it. So we're gonna do save. Oh, whoops. Make sure. Yeah, so these heads cannot write to this hard drive. So we got sort of kind of fooled, I guess, by it IDing, getting ready and all that stuff, but it didn't really give me any issues in the let me just refresh that. Oh, yeah, it's not gonna work. Didn't really give me any hints in the terminal that like, hey, listen, these heads are not compatible. It just gets ready and yeah, as you can see here, there are no errors or anything that would hint. Usually you get some servo marks here. I think I saw some of them actually in the other utility that before I closed it. So I think, yeah, we'll need to put a new set of head stack, a new set of heads in there, and that is the 8212 head stack assembly. Not this. So this had an 8212 or has to have an 8212 head stack assembly in there because we tried the C2 and that did not work. So 82 in this case is what we will need. Whoa. What a piece of shit. It seems so that my instincts were correct. The preamp that we actually needed was the 8202. not the C202 that I showed you guys before. So basically, we'll have to do this all over again, except this time we're doing, you know, twice the work, I guess you can consider it. Not quite, but it's more work. It's this is, you know, part of data recovery. If you don't guess on the first try, you're obviously going to have to keep trying until you get a match. So you know, when you narrow it down to those two preamps, obviously you have a 50% chance of guessing the right one. I knew which one it would be, which one would be the correct one, but I sort of ignored it just for this video to show you guys that just because date code matches does not mean you can find a compatible preamp. So I'm quickly going to go through this one. Obviously, I won't rush or anything like that, but I'm not going to you know, explain anything in detail or anything like that anymore. Just get to work, swap it out, and yeah, so we can move on. So let's get right into it. Oh, ha! Try to remove that without the screw, or with the screw, I should say. Let's get rid of that. All right. Remove the dust a little bit. All right, we want to slide this over the platter slowly. Okay. Let's take the patient away for a moment. This is the 8202 donut that I was telling you about in the beginning of the video. This is the one that we need for this recovery. So quickly going to remove this. quickly want to mark this just to make sure that I'm going to call it D2, so there's no mix-up. Okay. Actually, since I only have 2 head combs, I need to free one. So what I'll do is I will put the one that we took out, the first donor, we'll call it donor 1, back into donor 1, and I'll close it up and use that for another recovery because that is a C2 preamp, which is, again, rare to find. So before I open this up, let me go ahead and, well, here, let's just put it aside for now. Let's close it up. Let's close up donor 1. Now, generally speaking, frustration does kick in sometimes, doing this. You wasted time taking it out, putting it back in. You got to take it out, put it back in again. Pretty much the work, your workflow is interrupted. But it's not the end of the world. When this happens, that's why you need, a good understanding of what drives use what preamps and stuff like that. Otherwise, you're going to be wasting time trying a bunch of them. So let's quickly put this one back in there. Like so. So you want to make sure that the preamp is actually sitting, the ramp is sitting there flush, not moving or anything like that. Let's take this, put it here, get our magnet back. This a little bit closer and just sit this like so. All right, cool. Make sure this moves. Yep, we're good. Take. All right. Make sure the rubber gasket is not in the assembly itself, but around, because this one was stuck on it. So it's, okay. Give it some air. Put one last screw in there. Use our green light. Make sure there's nothing on the donor so that we can close it up, power it back on actually. And we want to make sure that there was nothing happened to the head stack assembly during this process. So it's very important that you check the donors that you try to use after the attempted recovery, because sometimes they do die during the process for whatever reason. So, yeah, this one looks good for the most part. No debris on there, so let's close it up. Okay. We're going to get our label that's near impossible to remove. Match it up. Okay. All right, so this donor goes back into the donor pile to be used for another recovery. But let's first check it, make sure it's good. I'm going to use the same port, SATA 1. Power this guy on, see what terminal says. Make sure there's no clicking or anything like that. All right, we have immediate terminal access. Let's refresh because this isn't the serial number, obviously. All right, beautiful. So this loads up. Let's see if we have sector access. So we're gonna go here, 0. Yes, we do. First to last, and yeah, this donor is perfectly fine. There was nothing wrong with this donor except incompatible heads. Let's set it aside for now, and bring our D2. Right. Oh, it's this guy here. I checked this donor before starting this video. It did show up. Everything was good with it. Sector access, all the good stuff. So we don't need to do that here. Let's get the screw in there. Yeah, sorry for the background on this. Probably gonna look hideous, but I did not get the mat in time for this video, so we just decided to. Come on. We just decided to make it without a mat, which is something I don't really like working without. But in this case, I had to just, because the camera was in this clean air room or bench. Okay, so let's get the head comb. First remove this. Okay. All right, again, you want to make sure you're free to go over the platters like so. We're good here. You know what, before I do that, actually, let's remove the magnet. Okay. So these heads look good. Just quickly inspecting them to make sure there's nothing wrong with it. Looks fine. All right, we're going to put our D2 away. Bring the patient back. Just remove the cover. So maybe zoom you guys in a little bit. Okay, just be gentle. Obviously, you don't want to damage any ribbon cables or anything like that. Make sure the rubber stopper is on here. Okay, we're good. First thing we're going to do is put the screw back on. Oh, well, I need the ramp actually before that. So let's put the ramp. Okay. You want to make sure that the ramp again is flush, not sticking out or anything like that. Now we can put the actuator magnet back on. Like so. Well, let's move this here a little bit. All right. Should click in place. Make sure the heads can move. Good. All right. Let's get the screw out of the headstock. If I'm mumbling, sorry. It's just I'm, locked in really and just focus on finishing this thing up. Turn off the light. Check it with the green light. Make sure there's no debris. As you can see, relatively clean, which is good news. So let's just clean up that side on the left there and the right. All right, beautiful. All clean. No debris anywhere here. Make sure everything is in there. Okay, we did not put the screw back in. So let's put that. That's why it's good to double check. All right, it's in there. The heads move freely. We can close this up. And go back to PC 3000. So let me just quickly close this. This is an extra. All right, let's put our label back on. Okay. All right, and let's take it to PC 3000. Let's see what happens this time. All right, make sure there's no clicking or anything like that. We do have this power monitor here, which is good. So it's loading, it's doing stuff. Okay, sweet. Do we have terminal access? Not quite. Okay, there you go. Let's refresh this ID. See, we do. You know what? Let's go into sector edit right away. Let's see if I get access to sector 0 without really doing anything else with 93. So let's go to sector edit 0 and no. Okay, so let's try. Let's go to here, repower. Zero zero 003 93. Okay, so it's reading it. Okay, so still not working. Here, let's work with. So this is, I'm gonna plug in donor 1. The reason I'm plugging donor 1 is to get a better idea of the terminal commands that I'm sending or anything like that, just the way the system that I have works. So is this an issue with the drive, or is this an issue with, what I have, the tools that I have? So let's do this. Let's restart the utility quickly. Let's go into SATA 1, auto. Okay, so you see this utility initializes perfectly fine. So this drive is okay in that regard. Let's try to do what we wanted to do, which is edit some options in system file 93. Yeah, so we're gonna do okay. We're gonna do this. Oh, I've already done this. So let's let's uncheck something. I don't know, just to make sure that it works. So here, let's do OK. And let's write this data to the drive. Let's see. Oh, well, first we need to do it indirect on this one. Okay. Make sure. Okay, that's good. And let's write it. So can these heads write? Interesting. So these heads did not write on the original donor. So donor one's heads cannot write to the service area. Is that what it is? Let's see. Well, let's do some troubleshooting actually. Okay, so we have that. We have sector edit access. This file loads fine. Or does it? This is the strangest thing. So this donor one, I am able to, let's just exit this. I am able to get access to the user area. So sector access here, a translator working perfectly fine, but I can't do anything with the service area. I can't write anything to it. I can't do any modifications. But at some point I did modify this drive. Because obviously we saw that it was changed. Those options that I was trying to untick, they were modified. So, And now I can't even read this file that I'm trying to.
Hello.
Yeah, what's up, Kevin?
Yo, can take a quick peep at ticket 28486.
Yo, man, I'm recording a video. I can't.
Oh shit, I gotta go.
What could it be? So, this is SMB31. Let's try to read system file 93 again. Where is this thing? Here. 393. It's very weird. Everything loaded fine here, but let's see here. So let's take this one. Yes. The save mode. Let's untick this. Okay. Let's write to the. So this is where I was having issues. I can't write it even though I selected ATA indirect, which is what you're supposed to do for this drive. So the writing capabilities. Actually, this time it worked. Huh. Yeah, just a typical day. I may have missed something in the old one. Actually, I may have not loaded the service area properly, but nonetheless, I could not read this system file regardless. So let's refresh quickly. Go into edit save mode. Okay, so the option that I chose is not there. So the system or the tools that I'm using to work with in this case do work. Everything works. I can. There was a hiccup with this drive, but for the most part, everything works fine. So back to the drawing board with the old one. Let me plug in patient drive. You know, this this is actually interesting because Did I have the compatible heads the first time and I just missed an option, you know, just going through quickly, or was it something else? But yeah, that's part of data recovery. So let's power this patient on, actually. See what it tells us. Yes. Let's see if I can read it by terminal. Okay, so we can. So let's just do here. Here. Let's go to. Let's see if I can refresh just by reading this. Yeah. So I cannot read system file 93 from this drive with these current heads. So this implies that we have incompatible heads. So indeed, head C2 was the correct preamp, I'm assuming, but I won't know for sure until I try it back in there and see if I missed anything. So it's very possible that the donor that I'm using, right, donor 1 in this case, is bad, but I doubt it because I've used you know, the C2 in general. I've used these preamps and they're not picky and they're not weak when it comes to like being able to be transferred from one drive to the other. This drive was actually a another recovery that I did that has some minor firmware issues. That wasn't a big deal. So the drive itself definitely was working at some point, but we don't know if that's the case here. So let's try one more thing here before we move on. So we're gonna hit this. What I noticed right away with this head stack is that everything is slow. Everything is writing super slow. Everything is loading slow, which wasn't the case with the older or donor 1, let's call it. Let's see here. So fresh ID. So ID we get. Can I load? Okay. What in the world? Do I have sector access? What? Okay. So, thank God I'm recording this, but this is a typical issue of what happens with these Rosewood drives. So, it's all captured with OBS. This thing took me down a rabbit hole, and I literally just restarted the utility and it started working. So I'm not surprised, and I've seen this before. Rosewood drives are just such trolls to deal with. Like, my God. This is a perfect example, actually caught on video, so I don't have to like explain this without showing you any like evidence or proof or anything like that. But we do have access to the first sector and the last sector, and this is ready to be cloned. So I'm not going to make any modifications with system file 93 in this case. I do see that the head stack is actually doing some relocation process and working in the background, so to speak. So the drive is doing some you know, background processes, but we're going to ignore that for now. We're not going to do anything to stop us from having this sector access that we see here, because this is actually this is a troll at this point. So I'm going to go ahead and quickly open a DE task. So DE is data extractor. That's what PC3000 calls it. So we're going to call it 30090. I'm not going to put the name, obviously, because it's not needed. What a troll. Oh my God. 30090 J.
You got it.
I got it, but
Data.
let's see.
This is going. This is much more like
30090.
the videos that I do than
Yeah,
the videos that you
it's. I shouldn't have done it with a Rosewood drive. It's anything but straightforward.
do. No, but that's the thing. This is reality.
Yeah, it
What
is.
you're showing people is reality.
Yep. All right, so we're gonna select the drive. So this is my drive. Yes. We're gonna use the physical sector. All right, we're gonna quickly build the heads map before this thing craps out. And I'm gonna go into Explorer right away to make sure that I clone the areas that have the data. Now, normally I clone the entire drive, but this drive I don't think I have much time with, and I think it's behaving really weird. So we're gonna go ahead and open up Explorer. Try to image only the used sectors in this thing. So that's what we're after here. So we're gonna go here. We're gonna go right click. We're gonna quickly make a used sectors map. So this person has 440 gigs used out of what is this, a terabyte? And yeah, let's get right to it. Really, just here. Let's see where. Let me just move this out the way. See where the chains end here. So for the most part, the last used sectors on this drive is in the 125 million range. So from 0 to 125 million. We're gonna go ahead and make copy. No, actually, I can minimize this here. We don't really need it. And what I do here is I pay attention to speed that I'm copying at, which is actually flying. It's 111, which is very close to what this drive is supposed to be running at. And make sure that none of the heads are weak or anything like that. Fingers crossed that this recovery is going to be complete. ETA for the clone to finish is about an hour and a half, give or take, maybe a little bit longer, hour. That's about it. So for the most part, this is a recovery that's successful. Now, I don't call a recovery successful until I have the data in my hand, right? So that's what I consider a successful recovery. We're not out of the woods just yet with this drive. So, this is obviously data. All the green bars indicate that this is transferring nicely, but I've seen the heads fail and go out in the middle. As you can see here, the speed has dipped down to 60 megabytes a second. It's fluctuating, and for the most part, I should be able to get all the data off of this. All right, so today's video was about a Rosewood head swap. It was on a 1 terabyte. I had 2 donors. I had to pick which donor was the most compatible based on the data that I've gathered over the past. It was the 8202 preamp, not the C202, as you saw. And yeah, so generally speaking, these drives do have issues when it comes to which donors they take, and they can trick you. They can make you think that the heads are compatible when they're not really. So it's something that to keep in mind if you're doing this, if you are in the data recovery business, or if you're trying to get into it. And yeah, that's basically it. In another video, I will make a video about the 7200.12 and show you a little bit on those, how they are on the insides. Those don't have the ramp for the head stack assembly. So the head stack actually parks on top of the platter. So it's an interesting video, I think it'll be. But one other important thing is that you want to make sure that you have a clean environment when you're working here. So there's no debris here. Everything is clean. And yeah, no interactions or no. That's it. And as always, I hope you learned something. Don't shoot. So the drive is not playing nice, but that's expected because it's a Seagate. What a piece of shit. But what the fuck? God damn it.